Hey Algebra 2 students, Miss Huss here. Just gonna do a video here today that's going to build off of what you did with Miss Yosea yesterday. So yesterday you focused on taking expressions that were already products and multiplying them using generic rectangles to be able to write your answer as a sum of terms. And so what we're going to do today is we're going to go backwards. It's going to be something that you've done a couple times this year, did a lot of times back in Algebra 1, and some of you feel confident on this, and some of you this is something that you've always sort of struggled with. So we're going to take today to kind of review how to factor and go the other way of what you did with multiplying yesterday to create equivalent expressions. So we're going to start with this first problem here. You need to find yourself some paper to follow along with these examples with me on. And we're going to do some factoring, and we're going to factor 2x squared plus 5x plus 2. And so right now this is written as a sum of three terms, the 2x squared plus 5x plus 2, and I want to rewrite that as a product of two binomials. And so what I need to do this is we're going to set up a generic rectangle like what you did yesterday. We're just, instead of going from the outside in, going from the inside out. We have the sum on the inside of the generic rectangle, and we're working our way to the outside. So right now what I'm trying to do is I'm trying to get all of this original sum to the inside of my generic rectangle. And so you're always going to take your x squared terms from your original problem, and I'm going to put it in this bottom left square. If you look back at your notes from yesterday, you should notice that that bottom left square is always where your x squared terms end up. Then you're going to do the same idea. You're going to take that 2 and put it in the top right square. You're going to notice yesterday that in the top right square, you always ended up with your constant in that box. Then, whatever the last two boxes are, the thing that we're missing from our original problem is that 5x. So whatever these two things are, they have to add up to 5x. Here's where the diamond comes into play, because you're going to put that 5x on the bottom of the diamond. We're using the diamond to figure out what two numbers we need to put in those last two spots in the generic rectangle. The other thing we know is that those two empty boxes should multiply to the same thing as the other two that are filled in. And so if I multiply 2x squared times 2, that gives me 4x squared. So what I'm looking for here is two things that multiply to 4x squared and add to 5x. And again, I got this 4x squared from multiplying 2x squared times 2. Okay, and so I'm going to have you think about what two numbers would multiply, or what two terms would multiply to 4x squared and add to 5x. And hopefully you figured out or paused and got 4x and 1x. Those multiply to 4 and add to 5. If you put 2 and 2, you got the multiply to 4 part, but not the add to 5. Those would add to 4x. So then you're going to put your 4x and your 1x, and feel free to write a 1 on here if you like. Need to go in the generic rectangle on either side. And now we're going to fill in the outside here. So I'm looking for any two things, and I'm going to start with the bottom left side of this generic rectangle. I'm looking for two things that would multiply to 2x squared. So you might be thinking to yourself 2x and x. Now if I put them like that on my generic rectangle, you're going to notice that this 2x won't multiply nicely to get me 1x. And so I actually want to erase that, and I want to put them on the other side, because 2x will go nicely into 4x, and x will go nicely into 1x. And so I fill in the outsides there. I'm going to double check, do 2 times 1 here. Does that equal 2? And it does, so that probably is a good indicator that I did this right. And then I put those two sides into my parentheses up top. So I'm rewriting that product, or that sum, as a product now. And we're just going backwards of what you did yesterday. I'm going to have you pause here and try one on your own. So it's going to give you a you try problem, and you're going to factor x squared minus 3x minus 4. All right, let's check what you just got here. So I'm just going to quick show the solution. And I ended up with a product of x plus 1 times x minus 4 with all that work shown here. So noticing that I ended up with negative 3x and negative 4x squared in my diamond. I was looking for two things that multiplied to negative 4 and added to negative 3. And then I filled those into the box. All right. So factoring with a generic rectangle is one type of factoring. We're going to talk about factoring by finding a greatest common factor, or a GCF. And so we've got 4 problems on here. Pause and write those down if you need to. And what I'm going to be looking for is the greatest common factor. Now, what that means is the biggest number that I can divide out of all of the terms in the problem I'm looking at. And so here, if I look at problem A, I've got 25x and negative 15. And I'm asking myself, is there a number or a variable that I can divide both 25x and negative 15 by? And there is. I can divide both of those by 5. And so what I'm going to do is I'm going to essentially undistribute a 5 from both of those terms. And so if I were to take here 25x and take a 5 out of it, undistribute a 5, I would be left with just 5x. I divide 25x by that 5 in the front, and I'm left with just 5x. And then I'm going to take my negative 15 and divide it by 5, undistribute it, and that gives me minus 3. And so if you can look at here, if I were to go opposite and distribute this 5 in here, that would give me 25x, and distribute this 5 in there, and that would give me negative 15, and I can go back and forth and kind of check my work that way. But all I could do here is factor out that greatest common factor of 5. Now the next problem is a little weird because I'm looking for a greatest common factor of 2x squared and x. And this time there's not a number that I can divide both of those by other than 1. But if you notice, the first term has an x squared and the second term has an x. And what that means is if the first term has 2 x's to give and the second term has 1 x to give, then I can take an x out of both terms. If I take an x out of 2x squared, what I'm left with is just 2x. If I take an x out of x, I'm just left with the number 1. And again, if you thought about the distributive property in your head here to check your answer, if you multiply that x into the 2x, that should give you 2x squared. If you multiply the x into the 1, that should just give you x. So you can kind of use distribution to check your answers. Now you're going to pause and you're going to try the next 2 questions. Finding the greatest common factor first, and then dividing both of your terms by that greatest common factor. All right, let's check your answers that you just got. So on the first one, my greatest common factor was 4, and I was left with just x plus 6 inside the parentheses. And on the second one, my greatest common factor was 3, and I was left with 3y, because 9y divided by 3 is 3y, and minus 5x, because negative 15x divided by 3 is negative 5x. All right, now we're going to put it together. So we are going to find, when a problem says to factor something completely, you're going to find a GCF first if you can, and then you're going to factor what's left in the parentheses if you can. So we're going to try this problem. We're going to try to rewrite this expression of 3x squared minus 12. First thing I want you to do is you're going to decide, is there a greatest common factor of 3x squared and 12? And there is. I can take a 3 out of both of those terms. And so what we're going to do is we're going to take 3 out of 3x squared, and that's going to leave us with just x squared. We're going to take a 3 out of 12, and that's going to give me just 4. Now, you're going to look at what you're left with inside the parentheses. You're going to ask yourself, can we factor this? If your degree is a squared or higher, 2 or higher, we should try to factor. If you don't have an x squared left in here, there's probably not going to be anything else to factor it by. So you're looking for, is this an x squared? And if so, then you want to try to factor it with that generic rectangle and diamond, okay, or the box and diamond. And so what I'm going to do is I'm going to set up a box and diamond for x squared minus 4. For now, I'm going to ignore the 3, but it does need to be part of my final answer, okay? So I'm going to set up my generic rectangle. I'm going to put my x squared in the bottom left corner and my negative 4 in the top right corner. Now, you're going to notice that the problem that I started with here doesn't have any x's in between my x squared and my 4. And so when I go to set up my diamond, I have 0 x's on the bottom of the diamond because of the 0 x's in my problem. I multiply the two things in the generic rectangle right now, and I get negative 4x squared. And so I'm looking for two things that multiply to negative 4x squared and add to 0x. Pause if you need to. Those two things are going to be 2 and negative 2, 2x and negative 2x, and you can put those in either order in the generic rectangle. Then you're going to fill in the outside. So you're going to ask yourself, what times what equals x squared? That's x and x. And then you can fill in the 2 and the negative 2 to get the sides. Check to yourself, does 2 times negative 2 equal this negative 4? It does, so that probably means I did it correct. And then I'm just going to write my final answer. I'm going to keep the 3, which was my greatest common factor, and then I'm rewriting x squared minus 4 as x minus 2 times x plus 2. Okay, what we're going to do is we are going to have you try one last problem where you're going to factor completely. So you're looking for a greatest common factor first if you've got one. Undistribute it. This time you're going to have to find something that is divisible by, or that you can divide 18 and 30 and 8 by. You're going to have to do it to all three of those terms. And then you're going to factor what you're left with inside the parentheses. Okay, let's do the GCF part first. Find your greatest common factor here. All right, so hopefully you realize, and I want to just jump back in here, that just to catch you so you could still try the generic rectangle box and diamond part if you couldn't figure the GCF out. But I can divide 18, 30, and 8 all by 2. And that's actually the greatest number that I can do that. And I'm left with just 9x squared. 30 divided by 2 is 15x, and then 8 divided by 2 is 4. If I look at 9, 15, and 4, I can check to see did I find the greatest common factor, because there's nothing else I could divide 9, 15, and 4 by inside the parentheses. Okay, I'm going to pause it again, and I'm going to have you factor what you're left with. You're going to write out your final answer. Don't forget to include that 2 in the front. All right, let's quick check your answer and show the work. So I ended up with 15x and 36x squared in my diamond, and I was looking for two things that multiplied to 36 and added to 15. Kind of tricky, but it's 12 and 3. And then you put those inside the generic rectangle, fill in the outsides, and you should get that answer at the bottom. Tomorrow you'll get a chance to practice all of this stuff, plus the multiplying with generic rectangles that you did yesterday in a Google form practice. Bye, guys. Hope you're all doing well. We're thinking about you all the time, as always, and hope that you're safe and emotionally doing okay. As always, contact us if you need anything. Bye, guys.